Welcome. Today I wanted to spend a little bit of time on an introduction to Terraform, a tool many of you maybe have heard about or maybe have played with, but I want to give a little bit of a more in-depth sense of what is the tool for, how does it apply to practices like infrastructure as code, and how do we really go from almost the very basics of what infrastructure can do all the way through to really thinking about the full infrastructure lifecycle management that Terraform was designed for. So at the core, the concept that's most critical to really understanding Terraform is this notion of infrastructure as code. So what does that mean at its heart? What it means is that what we want to do is move away from this model where maybe we manually manage infrastructure. We log into a console, we point and click, we log in, we run commands manually, to one where we really codify it, right? We treat it like a configuration file or like code where we're actually version controlling it, we're saving it to a system like Git, and we're managing it almost the same way we would manage an application's lifecycle, right? So at the heart where this starts with something like Terraform is a configuration language, right? So with Terraform, we call this HCL. It's the HashiCorp configuration language. And what it allows us to do is basically declaratively specify what set of resources we want to exist. And when I talk about a resource, this can be a fairly generic concept in Terraform. It's basically almost anything that you might imagine that you can create, modify, delete from an infrastructure perspective, Terraform can manage. So a very simple example of this might be, maybe when we want to declare a managed database, that database is getting accessed by our application. Maybe that's running a set of virtual machines, or it could be containers, or it could be a serverless application. Those virtual machines might be fronted by a load balancer. And so this might be a classic three-tier application, right? Load balancer to talking to a compute layer, talking to a database, right? So rather than spin these up and manage them manually, with Terraform, we would define them as code. We would define the configuration of our database as small, medium, large. We'd describe our VMs, what images they're running, how they should be configured. Our load balancer, we'd point it at the VMs. And what this analysis to do is run two very important commands with Terraform. The first is what we call plan. So in the planning phase, what Terraform is going to do is compare basically your desired configuration with your reality, the current state, to come up with an execution plan. So we're going to take desired state, which is specified as the config, plus the existing configuration or state, and that generates a plan, right? So the plan allows us to inspect and ask, well, what is Terraform going to do? Is it going to create a resource? Is it going to modify an existing resource? Is it going to delete something that already exists? So this is designed so that an operator and end user can have high confidence that they understand what Terraform is going to do before they do it. Once you've reviewed the plan and you're ready to make a change, that's when you run the other major operation, which is an apply. And what an apply does is it basically takes the plan, it applies it, and it creates a new state. Right? So we might go from state 1 to state 2, right? And so this sounds relatively simple, right? So you might start in a very basic case, which is, let's say you don't have anything yet created. You're sort of day 0, no infrastructure is running. Well, your initial plan is very easy. Because nothing is running and you want all of these pieces to run, your desired state is simple. It's just go create everything. So the initial plan of what Terraform will tell you is nothing's running. I'm going to create the database, the VMs, and the load balancers, right? And so when you run plan, it'll initiate all those things, and now you have your initial state. Now you have the first set of resources created. But as you get into day 2, now you maybe want to modify this. Maybe you decide, okay, I'm actually going to add a DNS record, for example, in front. And maybe I need to resize my database from a small to a medium. And maybe I need additional compute, so I'm going to add a new virtual machine, right? So this becomes kind of a classic evolution of infrastructure. Very rarely do we do it one and done and we never need to change anything again. Often we're evolving infrastructure over time. So what we would do with Terraform is rather than make any of those changes manually, we would come in and we would change our configuration. We would re-specify it. So instead of a small database, we ask for medium. Instead of 3 VMs, we ask for 4. And so we'd make these changes. And now the next time we come in and we run Terraform plan, it's going to analyze and say, well, now there's some differences, right? And so this is where Terraform will get more sophisticated in the plan. It will start to tell you and say, well, the DNS record didn't exist before, so this is something we need to go create. At the same time, you add 3 VMs, they already exist, but this 4th VM, that's new, so we have to go create that. But your load balancer, it has a dependency. It needs to know about the different load balance, the VMs. So once we create that fourth VM, we actually have to come in and we have to modify the existing load balancer. Same thing with your database. It was previously a small, now you asked for a medium, which means we're going to have to modify this configuration as well. So you can start to see, even though we'd made a relatively basic set of changes, the plan starts getting much more complicated, and there's a sequencing between these. We have to first create the new VM before we can modify the load balancer so that we know what the IP address of it is, right? The DNS might need to wait until that load balancer is updated so it knows the right load balancer to point to, right? So now the plan can give you a bit more sophisticated information. It's going to tell you, what am I creating? What am I modifying? What am I deleting? What's the sequencing of those things and the dependencies of them? And now when we run apply, Terraform will go execute those in the right order, and if anything goes wrong, it'll halt at the appropriate sequence, right? So you can start to see very quickly, we start talking about Terraform and we start talking about infrastructure lifecycle, right? Because day one, we did the initial creation, but then we started modifying it. That's when we start talking about day two. So often when we're talking about infrastructure, it's very rarely, like I said, one and done. It's easier to think about it as a set of life cycles, right? So I can think about day 0 as oftentimes I'm doing the initial foundation setting, right? Maybe this is complete blank slate. I don't even have an Amazon account yet set up. So how do I start and say, okay, I'm going to create my initial GCP account or Amazon account or Azure account and set up my core landing zone, my sort of virtual networks, my initial set of guardrails, etc. Day 0 tends to be that kind of landing zone setup, right? Once we've done that, sort of the foundation is in place, now we get to day 1, which is, okay, great, how do I do the initial deployment of my infrastructure and my applications, right? So in this case, that day 1 might have been when I bring up my load balancer, my 3 VMs, my core database. That's the initial bit of infrastructure deployment. And then infrastructure tends to live for a very long time, as long as your applications. So this is when you get to day 2, day 3, and beyond, right? All the way to day N. So day 2 might be when you came in and you said, actually, I'm going to add my DNS. I'm going to add a new virtual machine. I need to upscale my database. And this happens kind of forever. Throughout the life of that application, we're going to continue evolving it, modifying it. Maybe the image on the virtual machine needs to be patched. It's running an old version of Linux that needs to now be patched because of a known vulnerability. So this becomes that continuous care and feeding over the life cycle of an image. Maybe our app becomes really popular and I have to scale it up and add more complexity to it, right? Eventually, I'm going to get to end of life where I don't need this application anymore, and I can decommission it, right? Or decom, right? But in the meantime, I have to deal with day 2, day 3, day 4, etc. Oftentimes, we'll shorthand this and just refer to it as day 2 plus, because within this is where you have all sorts of things. You have to do your patch management and vulnerability management. You have to do right sizing, both because of scale as well as cost, right? You have to make, changes to new versions, deploy new infrastructure, change the architecture. Maybe you move from VMs to containers. Maybe you add a message queue in there. Maybe a Redis cache, right? So each of these things will require evolution. Of course, if you're running in a larger environment, you also care about things like compliance and audit, right? So your requirements might change if your PCI and the PCI specification and compliance controls change. Maybe your business all of a sudden wants to become a HIPAA certified, and that changes some of your requirements, et cetera, right? So as we go through, there's a whole lot of this complexity that sits in that day 2, day 3 environment, right? As we think about cost, how do we manage which applications are spending most in cloud? Which teams do we need to sort of notify if they're over budget, right? How do we optimize our spend if we have too many idle resources, for example? So all of these things start to come in play when we think about that life cycle. So Terraform, one of the key advantages is by moving to code, we can start automating how we think about every aspect of this life cycle. So up front, you can see how we define with code what the landing zone could look like and then automatically provision that. When we do our initial deployment, now we can do that same thing. As we care about some of these other concerns, such as patching, well, I can come in and change my image, for example. So it might be running version 1. I can rewrite that and change it to version 2. And now I can do things like use Terraform to actually automate repatching and changing all the machine images in my environment, right? As I think about right sizing, we talked about going from a small to a medium. Good example of this, right? Because of my load, maybe I need to go to a bigger database. But the reverse might be true. Maybe I oversized it, and for cost purposes, I'm resizing back down to optimize my cloud spend. So the core of infrastructure of code is enables all of these different things to be done in a way that we understand it. We can always look at the code to understand what the current and desired state of our infrastructure is, but then we can also put automation and guardrails around all of these other things, right? One of the key aspects that we often will talk about, for example, is the notion of policy as code. So the idea is, as we're making these changes, how do we make sure that they're being done in a safe way as well, right? So that's where we can apply things like, code, which is also based on policy. So for example, I might have policy that's looking at cost. I might have policy looking at security. I might have things that are looking at compliance or operational best practices. And the key is, as I'm going through this life cycle, and I can apply these in a programmatic way, right? So we start with that plan that took place, and now we know what is Terraform going to create or modify or delete. And in between that is before we get to the apply phase, where we've actually made changes to our cloud environments, is where we can start to take all of these policies and enforce them in that middle, right? So we can take the plan and inspect it and say, hey, you're about to create, for example, a new firewall rule that allows the whole internet to access something. That's not allowed because you'd violate a security policy. Or maybe you're modifying the database to turn off encryption. Maybe that's not allowed because you'd violate a compliance check. Or maybe I'm going to delete my VMs and only have one behind my load balancer. We don't want to allow that because from an operational reliability perspective, now we have a single point of failure. So each of these could be policies that get applied during that plan apply cycle, and we can use that to enforce whether or not those changes should be allowed. Now, when you start thinking about the different applications you're deploying, often there's a set of commonality. Every app isn't unique. You might have many apps that are Java applications. You may have many apps using a common type of database like Postgres or MySQL. So we don't want to have to reinvent the wheel on redefining these all the time. This becomes another key powerful aspect of infrastructure as code, is the reusability and the modularity of it. So in Terraform, you might start by defining a bunch of these as sort of individual resources and a unique pattern, but over time you'll notice that these patterns repeat. So this is where you'll often create what we call a module. A module might be something like, let's say, a Java application. The module might have multiple inputs. So for example, you might want to say, how many instances should I run? What's the jar file? What regions do I want to deploy the application to? And the output of this module might be, let's say, the DNS address of the load balancer. So this allows us to start encapsulating that complexity. Within this module, we might have this type of a pattern. It might be the Java app has a DNS record in front of a load balancer with a set of virtual machines or containers. That lives inside of the box, but the user can just consume this by providing the inputs and getting the outputs. This can then be published as part of a broader registry. So when we think about the Terraform registry, it's a way of creating reuse of these common patterns. So yes, I might have a Java pattern, but I might also have a C# pattern. I might also have one for my databases. So maybe I have one for MySQL, and I have one for Mongo, and one for Redis as an example. So each of these start to become reusable libraries, so that as my different teams are deploying applications to cloud, they're not all reinventing how Java and MySQL and Redis are managed. They can pull these things out, provide their inputs, and compose bigger and more complicated infrastructures, right? Now, each of these can also have their own life cycle, right? So we might say, great, I have my C# version 1, but now there's a vulnerability, there's a new version, I have to upgrade the runtime, for example. I can publish a new version. And this then gets into what we refer to as things like module lifecycle management. So oftentimes you might say, okay, at a large organization, you might have hundreds of applications that are Java app running in an environment, but if there's a new version of the JDK, I want to go now deal with hundreds of apps upgrading and deal with that in a consistent way. So this is where by having a common set of modules that are versioned, I can now apply lifecycle management, say publish a new version, deprecate the old version, notify teams that they need to upgrade, and enable sort of an automated upgrade path. So throughout all of this is where we've sort of designed multiple components, right? Oftentimes we start in kind of day 0, day 1, using Terraform Community Edition, right? And as we migrate into some of the day 2, day 3 enterprise challenges, that's when we might start to use something like our Terraform Cloud, for example. Because now we can start to apply these different practices to really make this easier. We can start to use things like a module registry and share this among teams. We can start to write policy and enforce that as part of the plan apply cycle. We can apply things like role-based access control to which users have access to change what set of things. And then we can start integrating with different systems to solve these different problems, right? So when we start talking about things, for example, like patching and vulnerability management, this becomes a key integration point with tools like Ansible and configuration management, right? When we think about things like right sizing or maybe doing cost reporting, this is an opportunity to integrate with various FinOps tools to be able to report on cost, optimize cost, do chargebacks to different teams. So this might be various tools like Apptio and Turbonomics and Cloudability. So each of these tools solve different kind of problems, and they can all be composed together using sort of the APIs of things like Terraform Cloud, right? Now, from things like security and policy perspective, we might integrate and say, okay, I'm going to use tools like Wiz, or I'm going to use Palo Alto's solutions, right? I can also apply things like policy as code natively within things like Terraform Cloud using either Open Policy Agent or using our native Sentinel engine, right? So we support both Open Policy Agent as well as Sentinel policies, right? So this allows me to start bringing these different workflows in. Right? From compliance and audit, I can start solving those things by having a clear visibility of who made what Terraform changes when, right? That becomes a key value of having it centralized through a system like Terraform Cloud, is I know what are all of my different Terraform workspaces, what changes did they make, what is each Terraform plan and each Terraform state file, and what changed between them. So it gives me better visibility and control so I can actually do things like have audit in a reasonable way, right? Because all my changes are being managed centrally, right? So this all becomes part of the sort of bigger picture of how do we start taking an infrastructure as code workflow and really scaling it up from something that works for sort of 1 or 2 people on a small team to something that's going to work at a large scale enterprise with hundreds of developers and hundreds of different teams, right? Ultimately, as we start thinking about this whole life cycle, there's many other problems. It's not just what infrastructure as code can do. I think through this whole thing, we have also challenges around things like image lifecycle management. So this is where we have tools like Packer, for example, where we apply a similar philosophy of infrastructure as code, where we want to define as code to feed into Packer, to then have it do things like build machine images, right? So this might be a VM image, like an Amazon AMI, or an Azure image, or a GCP image, but also could build a container image, like Docker, right? And so the goal is very similar. Day 0, day 1, I might need to bake a VM image or a container image, but then I might need a day 2 update that with a new version of Linux or a new version of my application or a new version of the Java runtime. So how do I build that new version and then publish it? And that's where that connects to things like HCP Packer. So here we can create a versioned image and then publish that out to a large organization, similar to the private registry. I might have a secure base operating system with version 1, and then I update it to version 2, and I want to publish it to maybe hundreds of different app teams that are each pulling in that image and deploying their infrastructure with it, right? So throughout that life cycle, we have to do the initial build of the images, to then we have to update them and patch them throughout their life cycle, and then ultimately delete them when they're no longer of service. And now as we think about moving up the stack, I think one of the common conversations is things like internal developer portals. So when we think about the goal of most developers, they kind of don't care about the details of how infrastructure is managed. Instead, they would like to focus on their application, their source code, and maybe a lightweight bit of metadata about their application. So our goal is how do we integrate that? And that's where our Waypoint product comes in, to really act as almost a translation layer, to really separate what's a developer concern from what tends to be an operational or platform team concern, which is how do we define the patterns for how these applications are deployed. So this comes back to things like I might define a Java pattern and a C# pattern and a MySQL, for example, and a Mongo. So a developer can kind of sit at their logical application layer and say, great, I want to build a Java app that requires a Mongo database. That's the level of metadata they care about. And they can provide that as input to Waypoint, which can then integrate tightly with things like Terraform modules to actually provision all of these things. So these become what we refer to as the set of golden patterns that are based off of repeatable modules that are infrastructure as code. So now whether I have 1, 10, or 50 of these applications, I can base them on infrastructure as code, manage them in a versioned way, upgrade them, do version upgrades, etc., but without necessarily having to expose all that complexity to a user who might not want to care about infrastructure as code or the details of infrastructure to begin with. And to enable them to operate, we take these patterns and we connect them to a set of actions. So you might, for example, have a Java pattern that needs to have a build action. So you can build a new version, you can deploy it. If something goes wrong, maybe you have a rollback, right? So each of these kind of core workflows has an action associated with it, right? And they might run different commands, right? Build might run our CI/CD pipeline. Deploy might need to use Helm to interact with, Kubernetes. Rollback might have its own set of instructions. So the goal is, how do we enable the platform operations teams to really define all of their patterns and all of their workflows in a codified way so it's repeatable and it's governable in sort of an automated way, and then expose it to the developers in a way that will be simple for them to self-service consume that without having to learn and manage all of this complexity, right? At the end of the day, the goal is we want to enable our development teams to deliver their applications across this landscape in an automated way, right? And I think the foundation to doing all of this is really infrastructure as code. That's really where the world has gone, right? And I think the power of Terraform is it enables us to do this in a consistent way across the whole lifecycle, but also across all of our different environments, right? What makes Terraform so flexible to this is that it has this provider ecosystem, right? So there's Terraform providers for all your favorite clouds, Amazon, Google, Azure, Oracle, etc., right? But also extends into on-prem resources like VMware and OpenStack. It can be hardware devices like Cisco networking gear, for example, or storage appliances. But it can go all the way up the stack as well to platforms like Kubernetes and SaaS services like Datadog or PagerDuty, for example. So all of these things can really be managed as code so that when we're delivering an application, it's not just the core infrastructure, it's everything around it. I can configure my Datadog dashboard that alerts on it, to my Kubernetes application, all the way down to my Cisco router that might underpin the network supporting that application. So that really becomes the power of applying infrastructure as code, is we can do full stack delivery in an automated way across the entirety of the lifecycle. Obviously, there's a lot more that you can learn and discover about Terraform. We have a lot of content on this, so I encourage you to check out the documentation, check out the other whiteboard videos we have, and get started with Terraform.